This is Patil, Professor, Department of Civil Engineering, Walchand Technology, Solapur. So today we shall discuss some basic things which are required for introduction to design of column. At the end of this session, students will be able to understand the concepts of design of column. Column is a compression member, the effective length of which exceeds 3 times the least lateral dimension. If the compression member, the effective length of which is less than 3 times the lateral dimension, it is called pedestal. So that means pedestal and column both are different. So it is here length is less than 3b and here length is more than 3b, where b is the breadth. Then the design procedure for the column holds good for the design of struts as well as for the columns. Columns will transfer the load to the footing, whereas the struts, they transfer the load from one member. These are the members of the truss which will transfer the load to another member. The column is considered to be short if its effective length to least lateral dimension is less than 12. If it is above, if the above ratio exceeds 12, then it is treated as a long column or a slender column. Then we are supposed to see about what is unsupported length of column, because we require unsupported length for considering effective length. The unsupported length of column, the first case will be the flat slab construction. Flat slab is one wherein you are having only slab resting on the columns. I will not read the slide because it will take more time. So a flat slab is one which is having a slab directly resting on the column, and here the unsupported length is taken from the head of the capital, and here from bottom of drop, and here there are no drop or no head, therefore it is taken directly from the bottom of the flat slab to the floor level. Next, beam and slab construction. If beam and slab construction is the beam of one depth may be different in two different directions. Accordingly, along x direction the unsupported length is different, and along y direction the unsupported length is different. And again, in case of columns restrained by lateral struts, if they are restrained by lateral struts, usually it will be 90 degree. So here, or even in some cases it may be a little variation. This, if it is maximum up to the 30 degree variation in the plan, then also we consider it is laterally restrained. So that means this is the length between the two struts which we are supposed to consider as a unsupported length of column. Then if a beam is, if the column is, if the beams are resting on the brackets, where bracket is having a breadth equal to the breadth of beam, so in that particular case the unsupported length is taken from the bottom of bracket to the floor level. So these are some of the cases where we are supposed to take the unsupported length. Next, effective length, it is by Euler's buckling load. It is a critical load or crippling load we call. It is equal to alpha into pi square E upon L square, where alpha is a constant based on the end conditions, both end fixed, both end hinged, and then one end fixed, one other hinged likewise. So alpha varies based on end conditions. So therefore crippling load, basically it is pi square A upon L square, where L is the effective length of the column. Then effective length, in which the buckling load alpha pi square E upon L square can be found for idealized end conditions. In practice, the end conditions are never idealized, they are a bit different. So for example, in case of a framed structure, it is difficult to idealize the end as fixed, free or hinged. So therefore IS 456 will give us in annexure E. In annexure E, they will give us what are the theoretical values of effective length to be taken for different end conditions, and what are the recommended values to be taken. We should take the recommended values. So usage of ideal end conditions may be assumed and effective length determined as shown in table 1 next in the next slide, or it is table 28 of IS 456. So, table 28 of IS 456 will give us the effective length. If both ends are fixed, the effective length theoretically it is 0.5 L, whereas recommended value is 0.65. We are supposed to take 0.65. Similarly, if one end fixed, another end hinged, it is 0.8 L we are supposed to take. If both ends are hinged, then it is equal to L we should take, where L is the unsupported length. Similarly, if it is having fixed at one end and restraint against rotation at the other end, then it is 1 L. Recommended is 1.2 L. And if it is partially restrained at the other end, in that particular it is 1.5 L. Similarly, if it is having restraint here against rotation and here also it is rotation is not restrained, in that particular case it is to be taken 2L. Similarly, effectively held in position at the one end, and if it is free at the other end, again it is to be taken as 2L. So that is how we are supposed to take the effective length of the column in the design. Then load on the column. The load on the column is transferred from the beams, and the self weight of the column is also to be considered. Then if the loads are eccentric, in that particular case it may be subjected to uniaxial bending, axial load in uniaxial bending, and axial loading with biaxial bending. So these are the three conditions we come across in case of loading on the columns. Then slenderness limits. The slenderness limit, the unsupported length of the L shall not exceed 60 times the least lateral dimension of the column. And if the ends are the given plane, one end of the column is unrestrained, in that particular case L should not be greater than 100 b square upon d, where b is the width of the column and d is the depth at that particular section. Then the minimum eccentricity. No column can have perfectly an axial load. So therefore, IS 456 give us the minimum eccentricity clause. Minimum is equal to L by 500, where L is unsupported length and lateral dimension divided by 30, and subjected to a minimum of 20 mm. That means even if nothing is there, then we should take, if this C minimum was ought to be less than 20 mm, we should take at 20 mm. If biaxial bending is considered, it is sufficient to ensure that eccentricity exceeds the minimum about one axis at one time. Then assumptions. In the limit state of collapse, the compression, the following assumptions are to be made for the limit state of collapse. In addition to the limit state of collapse which we have made out for flexure, that is for the beam, the maximum compressive strain in concrete in axial compression is 0.002. This is the maximum axial strain, compressive strain. Then the maximum axial compressive strain at highly compressed extreme fiber, that means if it is subjected to axial load and uniaxial bending, in that particular case subjected to axial load and uniaxial bending, in that particular case the strain with no tension at the other end, the strain when there is no tension shall be 0.0035 minus 0.75 times strain at the least compressed fiber. So this is least compressed fiber, this is extremely compressed fiber. If you want strain here, it is 0.0035 minus 0.75 times the strain at here. Review question. Recommended value of effective length for a compression member effectively held in position at one end but not restrained against rotation, at the other end restrained against rotation but not held in position, is 0.75 L, 0.5 L, 0.8 L, 2 L. Please guess it. One more question. If IS 456 clause number 25.3 imposes the slenderness limit for the column of unsupported length L shall not exceed 60 times the least lateral dimension of the column. That means L should not be greater than or equal to 60 times B, whether it is true or false. Please guess the answer. The answers are the recommended value of effective length for the first one, it is 2L for this particular case, and this particular statement given, it is true. The statement given is true. These are the answers. These are the references used for preparation of this. This will give you just preliminary ideas, but we are not entered into design process. For the design process, you are supposed to watch the another video, which will give you the design process of this particular column, short column, so on and so forth. Thank you one and all.